Chris, are there more people coming right now, or are we pretty much at full strength?
I don't think so.
Okay. So one of the big learning goals of the class is that, and something that many of you have already been practicing, is going to the literature, finding a procedure for a functional Lagrange conversion that you want to mimic, and then doing that in lab. Like multiple groups tried that today. Is they looked up a prep, they did their best to interpret that prep, and they're trying to replicate it, but on a different substrate, right? Like on a different starting material. So when you're doing that, just before we start, what things? First of all, when you're setting up a laboratory notebook, generally, what's in the laboratory notebook? Don't look at your current laboratory notebook. If you were setting up a laboratory notebook page, what appears?
Reactions.
Okay, everyone gets one. Let's do it in order from the top of the page down. Date, boom. We do the date. You have one, another one?
Or reaction scheme.
Yeah, reaction scheme. Sometimes people write like a title too if you want to write a title. So a title and a date, or a date and a title. And then there's the reaction scheme. What's in the reaction scheme? What's in it?
Conditions.
So conditions are one thing. Where do they appear? Over, around the arrow, above and below the arrow. That's good. So that's like an abbreviation of the conditions. What else appears in that reaction scheme?
Usually comes with chemical formula.
The chemical formula, perfect. That's really important. That's the only place the chemical formula appears often of the starting materials and the products. So it's really important to have the chemical formula there. So that's important. Oftentimes people will also write the molecular weight as well, the chemical formula and molecular weight. You can calculate it at the same time, right? You get the chemical formula and then you calculate the molecular weight. In the old days, we would always do that by hand, but now you could, if you're drawing it in ChemDraw, you automatically have that stuff. Okay, then what appears? So you've got a reaction scheme. Then what's next? What comes before the reagent table? The references. So pretty much every single reaction you run has some precedent somewhere. It could be a reaction you ran previously, and then you have to reference yourself, which is fine. Better if you're referencing like literature, like if you're getting the procedure out of literature and you're modifying it or something. You have one or two references then that appear. And then what happens? The reagent table, right? In the reagent table, how do we decide what goes in the reagent table? There are like sometimes different things that appear. How do we decide what goes in the reagent table? What always goes in the reagent table?
Reactions.
The name of the reagents. Yeah, and they appear like on the left in the left-hand column. What else always appears? Or what are other things that appear? Moles. Yeah, you need to have moles. That's another thing that appears. What's something else that appears? How much you calculate you're going to use. So you have a calculated column, and then you have an actual column, right? What are some other things that appear? What other columns are there?
Densities.
Densities if you need them, right? If they're liquids and you're using that can get to moles. Molecular weights, typically, or sometimes rather than a molecular weight, if you're using a reagent that's already in solution, instead of the molecular weight, you give the molarity. Like if you have a 1 molar solution of something and you're adding it, the molecular weight isn't what matters, it's the concentration that matters, right? So then you can convert a volume back into moles. Molecular weight helps you get to moles when you have like a mass of something, right? That's how you get back to moles. So you have to be able to get to moles somehow. And so one column is always the molecular weight and or the molarity of the solution. Right? Everyone comfortable with that? What's another column that's almost always there? Equivalence. That's a super important one, right? Okay. What else? So that's mole equivalence, right? It's the mole equivalence, not mass equivalence. What's another column that typically appears often? The last column is typically the solvent. So if you have a solid reagent, you're dissolving in a solvent, you write the solvent in the right column, the volume and the identity of the solvent. Yep, so that's the right-hand column typically. Okay, is everyone comfortable with that? So then what comes next? Then your procedure, right? So you would kind of write the word procedure, and that's where it would end when you walk into the lab, right? So this exercise is practicing what we're just talking about. I have like a transformation that for some reason you want to do at the top of the page. You found this procedure in this paper. I just opened up the newest issue of JOC and found a transformation. And I have so the transformation is shown there, the one that's done in the paper. There's the protocol. And what I want you to do is set up your laboratory notebook. So on the final, this would be a reasonable thing for me to ask, right? Like I give you a transformation you want to do, give you some literature precedent or give you a few literature precedents and you can pick the best one or something, and then you set up a laboratory notebook page. Yeah, that would be a reasonable thing to ask. Those are the course goals, that you be able to do those skills. So this is a practice. Yeah, everyone comfortable with that? So I have a copy for everyone, so everyone can do it on their own, and I have a blank piece of paper if you want to try. Just try to do it. And there may be information that you need that's not here. So if there's information that you need that's not here to set up your laboratory notebook, you have to ask. That's a hint.
You have to leave it next for it.
What? On the exam, I'll try to give you all the information, but on this exercise, since I know I'm going to be here, I will allow you to ask me questions. No, it's not like the other draconian lab thing. Lawrence, would you mind stopping the video because I think the action is over now.